All right, we're ready to start testing our test points for this problem so we know where it's positive, where it's negative. And if you look up here, remember we're looking for values greater than or equal to 0. That means we're looking for the positive values. That's what will make this true, and that's what we'll use to write our interval. So first we're gonna try the test point -4. So everywhere you see an X, plug in your -4, and I've written down here what it would look like. It's negative, so it must be enclosed in parentheses, otherwise your calculator won't give you the right answer. So -4 quantity cubed plus -4 quantity squared minus 9 times -4 minus 9. Then we'll take our calculator and type that in. So parentheses, -4, close our parentheses, then hit caret and cubed, and then we have plus parentheses, -4, close parentheses, then hit your x squared button, and then this is subtraction 9, parentheses, -4, and then subtraction 9. So that gives us -21, which means we need a negative sign right here because that means a negative answer. And remember what I said about the signs, because there's no solutions repeated, no double roots, the signs are going to alternate. So this next one should be positive. If it is, then we'll continue the pattern. So the next test point is -2. Remember, this isn't one of the solutions. It's in between the solutions. We call it a test point. So I specifically picked these two because we don't have to type it again. Hit your up arrow, and then everywhere you see -4 on top of the 4, type 2. So that put a 2 in there. On top of the 4, type a 2. And I think we have one more. There it is. So type a 2 and hit enter. And we get a positive, just like we predicted. Remember how I said the signs will alternate? So we got negative, then we got a positive. So that means this is positive, and you can do the other test points, but it's always going to alternate for polynomials as long as there aren't any repeated solutions. So now I have to decide which intervals are my answer. So I go back up here and this says, oh, greater than 0. Pick the positive intervals. Well, here's a positive interval and here's a positive. So now I just have to transfer those to interval notation. So we use brackets. We made that little reminder there. So bracket -3 up to -1. United, and you do have to have that. That's not optional. And that's because there's two different intervals that are positive. This interval would be +3 to the end of the number line, which would be infinity. So -3 to -1 inclusive, united with 3 to infinity. And that would be our solution. Okay. So those are all the x values, everything in between -3 and -1, everything from 3 to infinity that will yield y values that are positive. That means above the x-axis. So I could even go as far as to draw a rough sketch. I could say, okay, it's negative here, so the graph's down here. Then it goes positive at this point. Then it goes down and goes negative. And then it goes back up and goes positive. So that's what a cubic looks like, not V-shaped, but round. So it's like an S curve, up, down. So this tells me it's below the x-axis in this interval. This tells me it's above the x-axis in this interval. This tells me it's below. Plus means it's back above. So I know what my graph looks like now based on the sign chart. And you do a ton of this in 150 and then even more in calculus, because it's how you find derivatives and maxes and mins and all kinds of stuff. So that is something you want to make sure you know how to do. Okay, let's go ahead and start 15. We might not get it done in this video, but definitely in the next one if we don't. So a rocket is launched upward from a platform. I'm going to go back to big. And the platform's 100 feet above the ground, and you can see they already built that into the equation for us. This is the quadratic function that models a rocket, and it makes sense why it would be quadratic, because when you shoot things up, they go up in the air, and then they come back down. So they form parabolas. Their trajectory, I'm getting projectile and trajectory mixed up. Their trajectory will be like that. Anything that's thrown upwards because of gravity will have a parabolic trajectory. So it's not surprising. It's an upside down parabola, because if you're shooting the rocket up in the air, it's going to go up and come back down. So it's not surprising the leading coefficient's negative. And this is the rocket's height above the ground in feet and t seconds after it was launched. Those are huge parts of this problem. They're going to help you know what formula to use. They're going to help you label your answers. So big part of the problem. So after how many seconds will the rocket reach its, remember when we did 2 of these in our notes? 7.5 notes. The minute you see maximum, what's your head supposed to say? Find what's the highest point on the graph? The vertex. So if the parabola cups down, the vertex is the highest. If the parabola cups up, the vertex is the lowest. So the minute you read the word maximum or minimum, this is what your head should say. Find the vertex. So, since the equation is not, in vertex form, that means that we need to use that new little formula that I was showing you earlier that comes from the quadratic formula. So, opposite of b over 2a is how we find the x of our vertex. So right here we write x equals the opposite of b over 2a. But then I look up and go, oh, there isn't an x. What are they using in place of x? Well, you go straight to the parentheses and that'll tell you whatever's in parentheses, that's your x. So really, we're doing t equals the opposite of b over 2a. So here's my a, here's my b, here's my c. So the opposite of b will be negative 480 over 2 times a, which is negative 16. And hopefully you remember from the video in 7.5 that you can't type this all in the calculator at once. It won't give you the right answer. So what you have to do is work out the denominator and then type it in your calculator. So negative 32. So don't try to do it in one step, because it doesn't work when there's 2 factors in the denominator. So now we have negative 480 divided by negative 32, and that gives us 15. So 15, and now this is where it's important that you have your stuff underlined. This is t. T is time in seconds. So 15 seconds. Okay, this is the other thing we learned in 7.5. If I want to find the height, which is my y, well, I know my x now, or in this problem t. So just like we did for the vertex problem on 11 and 12 on the last page, we're going to do the same thing. We take our x or t, we plug it into all the places we see t, and that'll give us h. So h of, here's a t, so replace it with 15. And that's a notation that means the height after 15 seconds is, and then we do negative 16 times t is 15 squared, and you want to write this perfectly because this is what you're going to be typing into your calculator, plus 480 times 15 plus 100. So the height after 15 seconds is going to be, and now we're ready for the calculator. How are we going to get this all in the same screen? Okay, I think we can do that now, right? Because we only need this part of it. So that's what we're going to type in, negative 16 times 15 squared plus 480 times 15 plus 100. And that gives us 3,700. And so we continue using our function notation because that tells us everything we need to know. So this says the height after 15 seconds is 3,700 feet. And that is when it reaches its maximum height after 15 seconds. So if you were looking at this graph, it would be 15 seconds right here on the x-axis. So this is 0 seconds, 15 seconds, then it lands somewhere around 30 seconds later. But at 15 seconds, it will be at its very highest point on its trajectory. And height is in feet, so I labeled feet. And lots of times they have you write a sentence about this. So let's go ahead and practice. The rocket reaches its maximum height of 3,700 feet after 15 seconds. So the rocket reaches its maximum height of 3,700 feet after 15 seconds. So that would be the sentence that goes with the solutions. Okay. And this next piece is going to take extra paper. So you can turn over, you can't turn over to the back.